Today we'll be talking about the structure of kidney. Okay, before going to main disease, they are nephritic syndrome. Okay, now let us talk about the structure of the microstructure of the kidney. Okay, and that is glomerular barrier. Okay, glomerular filtration barrier. Okay, now let us draw a structure. Okay, just draw the structure. You can see in the figure as well. Okay, and this is efferent arteriole, and this is, they are the top of capillary. Okay, they are the top of capillary, and so this is, so they both are the arterial supply. Okay, and this is top of capillary. They are top of capillary are embedded in the mesangium cells. Okay, in between them there are presence of mesangial cells. Okay, now let us talk. Okay, so let us draw this, complete this structure. Okay, and complete this structure. This is efferent arteriole and this is efferent arteriole. Okay, and this is continuing. Okay, so and this is and this capillaries is surrounded by epithelial cells. Okay, endothelial cells. Okay, no, it is surrounded by endothelial cells. So it is surrounded by, this capillary is surrounded by glomerulus basement membrane. Okay, and this glomerulus basement membrane has two lining. One is endothelial lining, and next one is there is presence of another epithelial lining. Okay, so this is GBM, this is glomerulus basement membrane. Okay, and it consists of another epithelial lining. They are called as visceral epithelial cells. Okay, that is called as visceral epithelial cells. You can see over here. Okay, you can see over here, they are finger like projection. Okay, so they are finger like projection. These are visceral epithelial cells. This continues and form, and again there is lining, this continues. Okay, this is called as parietal epithelial cells. These are visceral epithelial cells, and these are parietal epithelial cells, and this is glomerulus basement membrane. And glomerulus basement, talking about glomerulus basement membrane, you can see in the figure. Okay, so there is presence of type 4 collagen. So glomerulus basement membrane is made up of type 4 collagen. So here is a dense collagen fiber, so it is called as densa. Okay, so what densa? Lamina densa. Okay, so that is lamina densa. So there is presence of type 4 more type 4 collagens, and there is presence of less type 4 collagens. So there is less type 4 collagen, so that is called as lamina rara. Okay, external rara, and this is lamina interna rara. Okay, so these are the things we have to know about. Okay, and now let us talk about same structure in the figure. Okay, now let me draw the figure. Okay, and you can see over here. Okay, so this is lining, that is endothelial lining. Okay, this is endothelial lining, surrounded by this capillary, top of capillary is surrounded by endothelial lining. This is again surrounded by glomerulus basement membrane. It consists of dense structure. Okay, and there is presence of visceral epithelial cells. Okay, there is presence of visceral epithelial cells. Okay, this continues is parietal epithelial cells. Okay, this continues is parietal epithelial cells. Okay, and now this is glomerulus basement membrane. Glomerulus basement membrane consists of type 4 collagens. Okay, and this type 4 collagens consist of alpha helix. Okay, three alpha helix. Okay, this 3 alpha helix you can see in the figure. There are presence of 3 alpha helix. Okay, and this 3 alpha helix consist of collagenous and non-collagenous part. Okay, this non-collagenous part is the most important part, because most of the important mutation, most of the destruction of this causes antibody production. Okay, so these are most common cause for antibody production against these cells. Okay, and there is no such name, but we can call as glomerular non-collagenous component. Okay, so mainly anti-GBM is produced against these cells. Okay, this non-glomerular non-collagenous component. Okay, so this is the main thing we have to know about. So we have talked about this structure. Okay, and the same thing, this continues and form peritubular capillaries. Okay, now let us talk about another most important things. Now you can see over here, let us same thing. Okay, and so lining. Okay, endothelial lining. So endothelial lining, and this is GBM. Okay, and so this is GBM. Okay, and again this one you can see over here. Okay, this is GBM, and there is presence of, in between these two epithelial lining, there is presence of Bowman's capsules. Okay, and so so we can know about that structure as well. Okay, and same thing you can see over here. This endothelial cell is lined by C halo glycolic acid, okay, that is negative charge, okay. So this is lined by negative charge, so this endothelial cell is lined by negative charge, okay, that is cialo, glycolic acid. And this is GVM, and GVM is lined by there are many structure like polyanionic proteoglycans, electronegative lamina, and fibronectin, okay. So these all are the negative charge, and here is also negative charge, okay. So negative charge, negative charge, negative charge. So these are the three epithelial barrier, okay. So anything to pass through the kidney, they must fight with this thing structure, okay. So this maintains negative charge, okay. So everything is fine. So if there is any anything to be passed, any protein to be passed, then they have to fight with this barrier, okay. So one of the most important thing is this, okay. So now let us talk about the three proteinase compound. They are albumin, globulin, and fibrinogen, okay. Albumin, globulin, and fibrinogen. Albumin is negatively charged, okay. So negative charge must be repelled, okay, and the globulin size is more, okay. So now let us talk about the pore precision over here. So there is presence of fenestration pore and the filtration pore, okay. So there is presence of filtration slit, okay. There is presence of filtration slit over here, this structure, visceral layer, and in here you can see over here there is presence of fenestration, okay. So there is presence of fenestration and there is presence of filtration slit, okay. Now these are the things, and the size of this fenestration is 70 to how many 100, okay, nanometer. So the size of the fenestration is 70 to 90, and the size of the filtration slit, that is 20 to 30 nanometer. Now next things, okay, there are three barriers, they are lined by negative charges. Next thing is there are pores, okay. There are the pores, there are filtration and the fenestration pore, okay. Fenestration pore has 70 to 100 nanometer size, and the filtration slit has 20 to 30 nanometer. So anything must be passed, must be crossed with, must be fight with these things, okay. So now we can imagine the nephritic and nephrotic syndrome pathophysiology, okay. Now these are the things we have to know about, okay. So let us now know about next things, okay. So so what happens if there is leakage of any damage over here, okay, if there is pore destruction over here or something else, what happens? So protein can hardly pass. So if protein to be passed, they must fight with this structure, okay. So now let's suppose there is pass of protein, okay. Okay. So if the protein compound like albumin is passed, then that is called only albumin is passed, okay. There is only destruction of negative side, then what happens? There will be little amounts protein will be leaked, okay. That is called a selective proteinuria. But if there is destruction of the pore as well as negative side, then there will be non-selective proteinuria, okay. That in that condition there will be both albumin and globulin will be goes out from the body, from the kidney, okay. So in non-selective proteinuria can again classify with two things. Non-selective can be classified again with two things, okay. Non-selective can be again classified with these things: less than 3.5 gram per day and more than 3.5 gram per day, okay. So this concept is the core for today, okay, and with this concept we'll be moving further, okay. Now next thing is if there is any disturbance, if there is anything, so what happens? The protein will be leak out, and when the protein leak out, what happens? There will be hypoalbuminemia. As a result, there will be damage to this structure. Finally, now let us stop, okay. Finally we can draw. Now we can draw this structure, okay. So you can line, this is vis lining and this is GVM. It consists of two area, okay, and so you can see again this is structure, okay. So you can, with this you can name everything, and you can imagine the disease process, okay. I hope you have understood the video. Thank you. Will be coming furthermore.